So can I address you as Mr. or like architect? Which one would be preferable for you, Mangesh sir?
Astronomer.
Mr.
Astronomer.
Yeah.
Yes.
Sure, sir. So I would like to give a brief introduction to sir. Um, so good evening, everyone. It's an honor to introduce today's speaker, Miss Astronomer Mangesh Sutar sir. With over 22 years of experience in global IT program, he is a certified PMI, PMP, RMP, and PFMP professional who has led multiple large-scale transformation initiatives worldwide. In addition, he has spent past decade deeply involved in drone and geoinformatics industry, actively contributing to UAV training, GIS application, and innovative drone solutions through his venture Propulse Consultancy. Beyond his corporate career, Astronomer Sutar sir is a passionate co-founder of Brahmand Darshan, an astronomy outreach initiative through which he has conducted stargazing camps, astrophotography workshops, and cosmic awareness programs inspiring thousands. Bridging technology, science, and community outreach, he exemplifies how curiosity, innovation, and cosmos can inspire us all. Please join me for welcoming Astronomer Mangesh Sutar sir.
Thank you, Aryan. That's for kind words about myself. It's good to hear about it. And as first of all, I would like to thank NASNI team, Hemant sir, and his other team members for giving me this opportunity on 15th talk about the astronomy. So basically, as I understand that NASNI gathers every first and the third Wednesday of every month and delivers some lectures related to astronomy, amateur astronomers, astrophotography, and related to space science and technology. So good to have this initiative done by NASNI, and I'm really thankful for giving me that opportunity to talk here. And my today's topic is about the International Space Station and Outpost in space. So as we are already aware that, people must have, or most of the people would have experience seen International Space Station across the sky. Some people may not have or seen it, but so this initiative actually we have started since 2021 during pandemic COVID times when people were actually, glued to their homes and were not able to move. So that is the time when we wanted students, people, general people, sitting from the home, how to, know more about the International Space Station and get a time to spot it wherever it, because this is one of the object which can be visible from anywhere in the sky at any given point in time. So you just need to know when it is visible from your particular location. And that initiative what we have taken up to the students, and then we created some sessions where you can build your own models International Space Station. So basically the idea about talking about International Space Station was almost like 5 years back when it was just completed 20 years. And just to update you, all of you, that we will be now being into the 25th year of International Space Station. So by November 2025, the International Space Station would be completing its 25 years in space. Okay, since it was built. In fact, it is more than that, but actually the full functional International Space Station was in 2001 around. Okay. So let's see what is the agenda of the today's topic. So it's basically the introduction. What is the ISS today? How does it looks? And the size of the ISS, technical configuration, launch vehicles, what was used, ISS modules, assemblies, scientific experiments conducted on the ISS. Then, we end with the session on the spot the station and then some reference around it. Okay, so this is what actually we normally do these. We regularly do these sessions for students in the schools, colleges, in general talks and all things. So mostly this would be around my around 20th of session on the ISS till date. So what is International Space Station? It's basically developed a research facility, international develops research facility in space being assembled in the lower Earth orbit. It has a microgravity environment in which astronauts conduct experiments in biology, human biology, physics, astronomy, meteorology, and other topics related to the science. It's a unique environment for testing of the spacecraft system that will be required for mission to the moons and Mars. So basically, that's what we said, outspace in the space. So basically, this is a platform which gives an astronauts or the scientists to test all the systems before going beyond the Earth orbit. Okay, so basically, if you want to reach to the moon or whether we want to reach to the Mars, this is a stepping stone for us. It is a complete home to the human beyond the Earth. It has been continuously occupied since November 2, 2000. Most expensive object ever constructed by the man. So it is almost 120 billion approximately. So this was 5 years back. Now I would say it would be around 150 billion approximately would have spent on it. This is the biggest joint project across by the people from NASA, that is from USA, Cosmos from Russia, ESA from Europa, and then JAX by Japan and CSA by Canada, and then small contribution from other countries as well. As there are almost like 18 to 19 countries who has contributed in building the International Space Station. So how does today ISS looks? So dimension is 171 feet long. It's 240 feet wide, so 90 feet high. It's almost like 1,500 cubic feet of living space. Weighs almost 47,000 lbs. The science capabilities, laboratories in space for 4 agencies. Orbital inclination path is 51.6 degree, covering 96%, or I would say 90% of the world's population. So maximum time you would see the ISS always most of the time over the population or populated area. Okay, the altitude of this particular ISS is 220 miles above the Earth, and at 17,500 miles per hour, it is moving across the sky. So it is traveling at a very enormous speed. So that's why if you see one orbit to complete around the Earth, it takes 90 minutes. So in a day, in 24 hours, it's almost complete 16 times orbit around Earth. That means the astronaut who is there in the International Space Station, he would be seeing almost 16 times sunrise and 16 times sunsets through the ISS. So the size of the ISS is almost like one of the football field, American football field, from end to end. So that huge, that big. So this is just to give an idea how big the International Space Station is when it is moving. Though it looks like just a tiny spot when we are observing through our naked eye, we will normally see it like a small star streak moving at enormous speed in the sky. But it's such a huge object in the. It's the biggest object in the space, man-made object in the space. Okay, so the technical configuration, you can see there are a lot of components. So all these components were built individually, sent separately by the rockets and spacecraft, and then they were assembled in the space. So this is one of the biggest engineering feat by the humans in the space. So this is like, like building the future colonies in the space for us to endure outside our planet Earth. Okay, so what are the launch vehicles which were used? So initially shuttle like NASA, then Proton by Roscosmos, Soyuz, which is currently also used by Roscosmos, then Ariane, ESA, and then JAX by HIBB. So these were the initial launch vehicles which were used for building or setting up. So it almost took 10 years to build the complete International Space Station in the space. So it is not that, it started and you have built it in 1 or 2 years. It takes almost 10 years, and now we are almost completed 25 years in the space. Okay, so let's see now how the ISS modules are assembled together. So it's basically started in early 90s. In 1990s, there was a individual programs were conducted. Like, Russia was trying to build its own space station. NASA was also in process of rebuilding internal thing. Then basically everybody was trying to build, but then looking at the mammoth size of the requirement over there, the amount of money need to be spent and all that things, it was not possible for one country to build such kind of facility into the space. And that's how by 1993 or 1995, there were a series of meetings, a series of discussions were happened. And initially, like US, Canada, Brazil, Argentina, European countries, they were actually, trying to set up a committee and started thinking that we need to build one common platform so that everybody can benefit out of it and others. And by 1995 or 96 onwards, Russia was also involved at that point in time. And then, the collaboration happened. And then by 1998, the first module, that is Zara. Okay, the Zara was the first module launched. Initially, it was planned to be launched under the Russia, but due to some problems of funding and all the things, it was pushed back to 1998. Then it was actually supported by the US government, and the first module was launched, which was built by USA, but it was launched by Russia. So Zara was the first module which goes into the space, and that is the first component or the first block of the International Space Station. Then came followed by 1998 the Unity module or Node 1, what we call. This is a connecting module, also known as Node 1, in the first US built pressurized module added to the International Space Station. It connects the Russian Zara and the United States segment of the station, and is where the crew can eat meals together. The module has 6 common berthing mechanisms. Okay, that means multiple others spacecraft can come and connect to this module. So this was like a junction for reaching out to the space station. Each CBM provides a mounting point for other modules. So if you see, the design of this particular module was basically to connect the Zara module from one end and then connect the other end to the other components as the progresses happen. But then again, there were another six, rather I would say four more additional CBMs were available, where the spacecraft from different organization, be it Russian, whether it is USA, Canada, Japan, or even European countries, they can also connect and patch to this particular module. So that's why it is called as a Unity module. So when this Unity module was launched, the connectivity between the Unity module and the Zara module was not a similar type, because Russian uses different types of hatching the modules, whereas the USA has a different way of modeling. So there was a requirement to mate both of these modules together. So that's why the pressurized mating adapter was designed, and which was connected to the Unity module. If you can see on the left side and right side, there are two PMAs. Okay, so those PMAs are basically nothing but the mating modules. Okay, so which you can connect different things. So you can see PMA 1 and PMA 2. And later on, PMA 3 was also added to the International Space Station. So these are nothing but these are mating components where different spacecraft can connect to the International Space Stations. So this is how actually in 1998 the Zara and the Unity connected by PMA. You can see PMA in between the two modules. You can see it here. So there is a Zara which is below with the solar panels. Initially, these were the first solar panels which was connected for powering the components using the solar lights or solar energy. And then you have a Unity on the top. Okay, so there is another picture also. Like you can see, this was a complete International Space Station. You can see in between the actual first module, two modules, the Unity and the Zara, which was connected in 2001. By 2021, the complete International Space Station was looking it like this. So the initial modules were at the center of the International Space Station. Then came the next module is Zeta service module, which was launched in 2000. It provides the living quarters, because by 2000 it was just the two modules, Unity and Zara, and it was just giving a remote support and all these things. It was initially building block for the International Station, but later on it was decided that that we need to conduct experiments, we need to do a lot of testing, a lot of what we say experiments needs to be conducted into the space. So that's why I need astronauts to have some space to save. So that's why this service module was designed, and it's basically a living quartered waste management equipment support, life support system, communication, control equipment. The module has again 4 docking ports also. This module also has a different ports. It includes propulsion system, because every time you see, whenever the international space is moving around in its orbit around the Earth, it loses its altitude. It comes down, so it needs to be corrected. So it has its own propulsion. So initially, there was a propulsion system which was used. Right now, we do not use propulsion system, because there is a new mechanism which has been put into the International Space Station, where you don't require really a propulsion system. Now there is a different mechanism which is used without using any propulsion. Still, the International Space Station can be into its orbit every time. Okay, so there were different mechanism which was there provided into this particular module. So this was launched in 2000. After this module was launched, then there was another additional component was added, was Canada Arm 2, that is 2001. Before that, there was another Canada Arm 1 which was there. Initially, if you see the first module which was launched, Unity, that point in time, the Canada Arm was there in the space shuttle in itself. So this was basically a second Canada Arm 2, which was connected to the International Space Station. Basically, it is a space station remote manipulator system, which helps, or which is actually a robotic arm used to assemble and service the International Space Station. It has almost 7 degrees of freedom and features latching end effectors at each end. So both the location, it can move from its one position to another position by changing its connectivity over the International Space Station. So it has those power data grapple fixtures located at the strategic point around the station. So it can that arm also can change its position on the International Space Station from one location to another location. So both ends, either one end gets connected to the International Station, other end is a fixture or a grapple which can connect and capture any object or anything what is required. Like lot of time you would have seen in recent times, whenever the Dragon, actually the SpaceX Dragon spacecraft reaches to the International Space Station, the robotic arm basically captures. Or even recent time when the Exom mission 2 was launched, that point in time, even that Dragon was also captured by the robotic arm and then docked with the International Space Station. So basically, it's a mounting point for arms and permit power and data connection to be made. The arm can be repositioned itself from one PDGF location to another using inchworm-like movement. So from one location, the arm itself on the International Space Station, it can move to the different locations. So this was one of the important component of the International Space Station while building the International, and currently it is just been used only for capturing the spacecraft modules, whether it is carrying astronauts or whether it is carrying a food supply or any kind of a cargo. Then there was another module which is basically these are the now components which comes are actually the labs or the practicals or the laboratories which were built to test all the experiments which are going to carry it out into the International Space Station. So the first module was Destiny Laboratory module. This is known as US lab located between Node 1 and Node 2 and considered as the core of the American section. So this particular laboratory belongs to the American people. So basically holds 24 standard size modular racks. These racks are used for different purpose. So it has a lot of components. In the International Space Station, since there is no gravity over there, everything is moving around into the space. So a lot of things needs to be put in such a way that they need to be fixed to one particular location. So, you can't just leave things lying here and there. And so there are a lot of racks or there are a lot of components which actually fix or keeps the things in the space. So these are called modular racks, and they basically life support equipments, robotic control station, crew quarters, waste management system, storage, various scientific experiment designed to be installed in the orbit. So basically, this particular module also had initially a high quality window of diameter of almost 20 inch located in the side of module. The window can be used for photography and other Earth source equipment. This was initially a small window to see from the International Space Station about the outside location. Okay, so this was initially a view for a astronaut to the outside world. Then came the next module is Harmony. This is basically between the Node 2. The Node 2 module includes 6. Again, these also are, so multiple ports are there. 6 CBM ports are also again available here. Pressurized mating adapter is also there around this. And Node 2 was constructed by the Thales Alenia by Space in Italy. It was launched in 2007. Basically, it again provides the living and working space for astronauts, acts as a passage to international lab modules, and offers docking ports for commercial crew and cargo vehicles. Then came the Columbus laboratory, which was again launched. This is now the European component of the laboratory. As we said, Harmony was earlier from the, or Destiny was from the USA. Similarly, the Columbus laboratory was launched by ESA. That was in 2008. This allows a station crew member to conduct wide variety of research in weightless environment. Columbus also accommodates external payloads in space science, Earth observation, and technology. Basically, there are two external fatalities are attached to the Columbus, exposed to the vacuum of the space. Colombo is attached to the starboard port of Node 2. So you see, this is not actually in between the International Space Station's line of thing. This is externally on a separate side. It is connected, so it is exposed to the outside international space also, so that you can have a future expansion. That's what the initially ESA planned to do it like that. But there was no such further development as has been done by ESA. They continued using the same module for the years now. Then there was another lab which was added by Japan, which is called Kibo Laboratory. This is basically consists of three main components, including Kibo pressurized module, experimental logistics, and the exposed facility. Again, this was also a separate module which was exposed to the space. Uh, this basically enables astronauts to investigate a variety of space phenomena, experiment range from biophysics, technology, and more to take from Kibo numerous research tracks. Kibo also provides the airlock lock experiments to expose to the vacuum of the space. So they also wanted to test a lot of modules which are related or exposed to the vacuum of the space. Then came the Tranquility node. This is also node called as Node 3, is a module of International Space Station. Also, this also has 6 CBM ports and can be fitted with up to 8 standard payload racks. It contains the environmental control system, life support system, toilet, exercise equipments, and observation cupola. So now this module has an additional component called cupola, which was actually an observational deck for the astronauts from where they, and it was always facing the Earth. Whenever you see the International Space Station, you will always see that the cupola is always facing towards the Earth. So basically, that is the platform from where the astronauts actually can see the Earth at any given point in time when it is actually moving in the orbit. Okay, so this is cupola. Cupola allows the panoramic view of the space and provides robotic control station from the operating Canada Arm 2 and Dextro. Basically, this was launched in 2010. So almost after 10 years, they got the view to see the actual thing from the outside. Though they had earlier a small window which was there, as I told you earlier on the first module, it was there. But that was a very small window from where they could actually see outside the space and all the things. Whereas this cupola gives them the complete 360-degree view, and it has almost 4 windows panes, and then there are central panes are also available. Basically, each pane is basically 25 thick. Outer pane was protected by the space debris. So there are, you can actually completely cover the cupola to protect itself from the space debris, because there was one incident where a micrometeorite was hit the glass and there was a crack, and almost the spacewalk has to be conducted to the replace the pane of the cupola. So this is again the interior view, small module designed for observation of operation outside the station, such as robotic activities. A lot of time you need to see and do the things over there. From cupola, you can actually see the things over there. So it has 6 side windows directly. NIDAR viewing window provides spectacular view of the Earth and celestial objects. The windows are equipped with shutters to protect them from the contamination and collision with the orbital debris or micrometeorites, as I told you. So let's see how many people have visited. So till date, almost by the time I speaking to you now, it is when I made this was 280. Now it is almost 290. People have visited International Space Station in last 25 years, almost representing 26 countries. 5 international partners have visited International Space Station. The first private astronaut mission from the station was EXOM Space Mission 1. And recently we have seen Mission 2, where Indian astronaut also has visited the International Space Station and carried out by SpaceX Dragon. So 13 private visitors known as spaceflight participants also has visited the International Space Station in last couple of years. So working outside the station, astronauts can exit the station using Russian docking compartments like Pierce and the joint airlock called Quest. So these are the 2 locations from where the astronaut can exit from the International Space Station for conducting various activities on the International Space Station, because a lot of time the repair from the outside also needs to be conducted, or a lot of servicing has to be done from the outside part. Like some time back, there was ammonia leakage was happening on the International Space Station, which needs to be fixed, or it was very dangerous for the International Space Station. So a lot of time, lot of repair work, not only from the internal part, but also from the outside of the International Space Station has to be carried out, where actually astronauts has to come out of the International Space Station and, do those repair work or the servicing activities on the International Space Station. So let's see the numbers. ISS, by the numbers, we almost have 25 years in the orbit. So as I said, continually occupied since November 2000. So by this November 2025, it will complete its 25 years in the orbit. As I said, 290 visitors from 26 countries has visited the International Space Station. At a given point in time, International Space Station can connect 8 spacecraft to the ISS. I have seen pictures where somewhere around 6 spacecraft at a point in time was connected. There was pictures around it. Almost 961 hours of spacewalks are conducted into the space. There were 110 launches till date time. It has almost 32,000 cubic feet of pressurized volume. The weight of the International Space Station is almost 925,335 pounds in orbit. Let's not talk about the meal eaten, but I can say the software which is being used to control the International Space Station is almost of 1.5 million lines of software code. So that's a very huge code which controls and manages and keeps the International Space Station functioning over there. It consumes almost 90 kilowatt of power, and that power basically is a complete power generated by the your solar panels over there. And almost, I would say, 1 lakh people across the world uses and works for the International Space Station. Okay, so that's these are the some facts which I have captured from the NASA's website, ESA's website, and various countries which are involved into keeping the International Space Station functional. Um, Unfortunate, I would say that right now the International Space Station would be retiring in some time, and you must have already heard that SpaceX has been given the order for decommissioning the International Space Station in some time. I think probably a couple of years later down, you will not have ISS, but then individually uh, uh, their own space stations would be there. Like every country might have its own space station. So a lot of time, as I said, astronauts are been staying. A lot of time we need to supply. At any given point in time, there are almost 6 astronauts in the International Space Station. Maximum, we have seen 13 astronauts at any given point in time. Even the last time when Axom 2 mission was conducted, that point in time, there were 11 astronauts at point in time in the International Space Station. But highest what we have seen is the 13 astronauts at any given at point in time in the International Space Station. So a lot of time we need to provide a cargo about supply, and even transport of the crew has to happen. So earlier it was the space shuttle which was used, but then due to the issues or challenges with the space shuttle and stopping the space shuttle activities, it was left to the Russian crew, as well as the Russian facility which was available that point in time, which was Soyuz, was used for basically transporting the astronauts to the International Space Station, and the Progress was used for basically transporting the cargo and all the things. Similarly, there was like Cygnus was there, then extended Cygnus was there, then ATV was there, HTV was there from Japan and all those things. Then came the SpaceX, which actually by which actually American back into the business, and they were actually were initially used Dragon to supply the cargo, and then Dragon 2, which was actually used for transporting the astronauts to the space station. So right now, both Soyuz as well as Dragon, which actually are being used to transport the crew, as well as the Progress, and there is another Dragon which is actually used for transporting the cargo to the International Space Station. So last 25 years, the astronauts aboard the International Space Station has conducted multiple science experiments, which cannot be done anywhere. So basically, this is where we need to test a lot of things, how things would behave into the microgravity environment, or where you do not have test. And this basically enabled us to simulate the situations when we are into the space travel, like be it the space travel to the moon or maybe towards the Mars, which is actually our next human exploration or endeavors, which we are seeing. Like a lot of countries or a lot of space agencies are also gearing up for the long duration travels as well as activities, which probably would get conducted in next decades over there. I could say, I mean, by 2030 or 2050 max. We could see people again settling or maybe moving to the moon or Mars. That is what everybody is dreaming about it and envisioning about it. So there would be a colonies on the moon, or there could be a colonies on Mars also in next 25 years of. During the past 2 decades, the space station has supported numerous discoveries, scientific publications, unique opportunities, and historic breakthroughs. This research not only help us to explore further into space, but also back benefits on the Earth. Okay, so whatever the experiments we do conduct on the International Space Station, they not only help us for the space travel and all thing, but back to the Earth also. A lot of these are being contributed for our best part of the human life. So ISS provides an excellent view platform of the Earth, covering almost 90% of populated Earth. Station crew has taken more than almost, I would say, 2 lakhs of images of the Earth. Students from hundreds of schools, United States and other countries participate directly in ISS research activities. Thousands of other schools use video clips and imagery from ISS to supplement their science curriculum. So that's how the science has been conducted, and it has been benefited for people, and lot of curiosity and lot of interest has been generated because of uh, 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 all the human collaboration across the globe has immensely helped the humanity. So major experiments what are being conducted on the International Space Station is like effect of a long-term space exposure on human body. You must have seen a lot of astronauts who had stayed on the International Space Station for almost more than almost 300 plus days, or even some are more than that also. I mean, and they basically study how the longer duration of stay into the international space. Like we have seen on Sunita Williams also, like she went to International Space Station for a day of 5 day trip, but then due to some problem on the return capsule or return spacecraft, she has to extend almost for 7 months over there. And we have seen how it has affected her health when she came back to the Earth. Okay, how she was lost her weight, and the bone fatigue and all the things. Similarly, ultrasound scans, diagnostic treatment for medical conditions in space also been tested over the study of near weightlessness, microgravity environment, on evolution, development, and growth of internal process of plants and animals. These are also been tested. A lot of biology and botany experiments are also conducted over this. Investigation of superconductivity and the physics of fluid in microgravity is also very important subject, which is extensively studied into the International Space Study. Then study of efficiency of burning and control of emissions and pollutants. These are also been studied effectively. Then study of cosmic rays, cosmic dust, antimatter, dark matter, and universe. I mean, these are some. I mean, there are a lot of experiments which are conducted. I can't list everybody, but these are the something which are very important, which I have listed over here for you to know. You can go to the NASA website or ESA website. They have put up the complete list of whatever the experiment. Even we can also suggest the experimentation or something which we can there. Probably if it has been selected, probably they will allow you to provide the details about it and all the thing, or maybe considered for future testing or future experimentation into the International Space Station. Okay, so this was how about the mission continues. So this is going on. So till the time the International Space Station is there, it continues to space exploration. It is the only platform for learning how to live and work during the longer missions in the space. It's where we are learning how to combat the physiological effect of being in space for a long period of time and serve as a unique test bed for innovative technologies. We will continue to conducting research on the station to support space exploration goals and to fulfill our commitment to our international partners. Okay, that's what we actually normally will see through the International Space Station. Uh, like when I built this presentation earlier, this was almost like 2020. So that time it was 20 years. So right now, as I said, we have almost 25 years of space station in the orbit. So now, as I get curious, most of the time, a lot of people ask me like, how do we see and how do I spot the space station? So basically, there are a lot of apps which are available. There is an app by NASA itself, spots the station. You can download on your mobile, and it will give you the particular location on that point in time when the International Space Station would be available. My favorite is actually Heavens Above, which actually normally use to check the exact and accurate pointing of the International Space Station from my city. So basically during the COVID pandemic time, we had actually did a session where we had helped students to understand and tracks. So there were almost during that time we had almost 4 to 5 space station spotting activity was conducted. Though nobody was able to meet each other, but from anywhere, wherever you are from the part of the city, you can see the International Space Station. You can click the photograph by using your mobile and everything and share it. So that's how we actually helped students and the people to collaborate each other. And, it was a really engaging activity for students to understand about the space and the astronomy and the technology which is used to build the International Space Station and the experiments which are conducted for the space exploration. Okay. And the last most important, as we want to continue this curiosity about the ISS, we also had helped students to build some models. So we had circulated a PDF copy of the module, which is available online. You can search to build a model ISS also online, or we can also share it to the team where they can circulate to the students, where you can just take a printout and you can really build this particular small module at your home and understand how the each module or each components is there. So it has almost all the modules which are there currently into the International Space Station. It's just a small miniature model, paper model, which you can cut and help you to help students and children to learn more about the International Space Station. Okay, so with that, I complete my topic on the International Space Station. Any questions we can take? Anybody has any questions related to International Space Station or how to spot the International Space Station? I can take up that question.
Yes, you may tell us how to spot the International Space Station.
Yeah, so basically, as I told earlier, that there are app Spot the Web Station. There is an app available you can download, and you can give your coordinates of your particular location, because at any given point in time, like for example, we are based out of Mumbai. So from Mumbai, when it is visible in the app, it will tell you all the particular date and particular time and location, whether it is visible in the morning sky or whether it is visible in the evening sky. So depending upon, like for example, people might be belonging to Delhi. So not necessarily when it is visible in Mumbai, it is not visible in Delhi or probably in across the globe. So wherever you are in the around the globe, any location you are there, you have to put the coordinates or your location details. Accordingly, it will tell you about how you want to do, how you want to search it. Okay, or there is a website also available, Heavens Above. There is a website available by name Heavens Above. Basically, again, on that also you can create your own login and you can set up your location over there. And based on your location, it will tell you when it is visible from that particular location over there. If anybody really wanted to interested, I can demonstrate you about the how to track or how to find the International Space Station.
Yes, please.
Yeah.
Mangesh sir, please do
Yeah,
the
I'll do it.
demonstration.
Yeah, I'll do it. I'll just 2 minutes. Let me open my browser. Okay. I hope everybody is able to see my browser. And I have just typed in Google Heavens Above. So you just have to type Heavens Above. And then you can basically you can log in. So I will log in by my login, because my login will give me the location. So I have set up multiple locations. So as I do stargazing events. So right now, if you see, today is 20th August till 30th of August uh, from Mumbai. So this is basically Mumbai. On the right side, you can see Mumbai is written here, right? So in Mumbai location, International Space Station is not available for visibility. So let me say the next, what is the next visibility? So if you see on 5th of September, I hope everybody is able to see now, right? From 5th September till 8th September, there is a clear visibility of International Space Station from Mumbai location. So similarly, you can change the location based on your location coordinates, and then you can see whether it is visible. So right now, if you see here on 5th September at -1.6, that is at 19, that is almost 7 30 onwards, it will be. So if you click on particular date, it will give you the graph also, how it will be visible to you in the sky. So you can, it is a very low visibility. You can see here, it was having a very low visibility. So this is not really fruitful because it's very close to the horizon. Let's go back and see something better. Maybe let's see next day, 6th September. Okay, again, this is good, but still it is very close to the horizon. Normally, we should have a streak of passing of International Space Station on the graph or on the chart from the center. Okay, which is very, so that if you see here, now here, see the magnitude is almost very good. Minus 3.1 means it is a very bright object in the sky. Okay, or minus 3.7, minus 3.5. These are very good magnitude or brightness value. So if you see on 6th, like there are 2 times you can see on 6th. One is in the early morning, that is 5:23, and then is again on the 6th September, you will see it in the evening, that is 8 p.m., 8:19 p.m. Okay, so if you see here, probably this would be little bit higher in the sky. You can see here, but the time is very less. Okay, you can see here from 2018 to 2022. So almost just for 4 minutes, it will be visible in the sky. Okay, let's see again the next on 7th September. Probably this will be a good view. So you can see it is almost crossing the entire chart. So this is a very good time to see actually the International Space Station. So on 7th September, you can see from 1929 till 1936. So almost for 7 to 8 minutes, it will, and it is crossing across the sky. So this is a very good time. And since it is 8:19, that is 7:30 almost, 7:30 onwards till 7:36, that almost 8 minutes you can see across the sky. So if the sky is clear, probably that point in time, the people from Mumbai can see the International Space Station. Again, on the 8th September, again, that is a 3.5 magnitude. So you can see again, this is also good, but this is early morning. So you have to get up early morning to see the International Space Station. So it's from 5:22 till 5:29, and it is crossing across the sky. So it will high up in the sky, and it will be beautiful. You can see actually the other constellation like Orion and all the Jupiter, Venus, all those will be visible. And provided, since it's a monsoon going on in India, if the sky is clear at that point in time, we can see a very beautiful International Space Station moving across the sky. Lot of time I have seen it from the Mumbai. Multiple times I have seen it. I have also captured on mobile the streak of the light which is go across the sky. A lot of time I post it on my groups of astronomy where people ask about any activity or anything. So this is one of the very good activity for students to witness about the International Space Station and see themselves in the sky. Right? Okay, so with that, if we have any other questions, I can take up.
Thank you very much,
Hello, sir.
Mangesh, sir.
So I
Yes,
have a
Amol.
question.
Yes, please go ahead.
Yeah. So my question is, like, we have seen so many people going to space at the ISS. They are
Yes, go ahead.
working over there. Do they carry the oxygens in the cylinders, or what is the way?
Really very good question. So basically, when the NASA and the Russians were building the International Space Station, so initially, if you see, first 2 modules were not having the components where actually people can stay. So basically, there are a couple of things which are really required for humans to stay into the space. The one of them was the important commodity is the air or the oxygen to breathe. Okay, so we can live without water for 3 days, but we cannot live without oxygen even for 3 minutes. Okay, so oxygen is the very precious commodity over there. So initially they used to carry the oxygen and theirs, but then it is very difficult every time because sending the cargo itself is a very expensive activity or while sending it over to the International Space Station.
Yeah.
So basically, initially they were carrying the oxygens, but now there are components which are been there, or there are systems which have been put up there, basically they send water. So it's not sending the oxygen, but they are sending waters, and through the water they are converting the chemistry about, you can
Yeah,
heat up the H2O by hydrogen and the oxygen, and the oxygen is being utilized for the
yeah.
astronauts.
And yeah, so one more question.
Yeah,
Like we know that the ISS has been revolving around the Earth for past 25 years.
right.
So does like we know that the interstellar dust uh, affects everyone. The radiation affects everything in the space.
Right,
So
right.
how do they manage the what we say the interstellar dust or the meteors or
So are we saying that the meteorites or micrometeorites hitting the International Space Station,
yeah
yeah, so there are a lot of incidents has happened in past. As when I was giving my talk, I told you that even the cupola window was affected by the micromite.
yeah
You can see it was
yeah
having a scratch, and
yeah
it took a lot of mammoth effort to replace that glass. Okay, because it was a very heavy glass, and then replacing such thing in the space is a very difficult activity in itself. So definitely,
mm,
lot of time International Space Station is being affected by the micrometeorites or meteorites or even space debris. So there is a separate team which sits in NASA Houston who actually manages this kind of threats to the International Space Station. So basically there is an area around the space station which is defined as a three zones. One is the red zone, then there is a yellow zone, and there is a green zone. So anything which
okay
is in a red zone is a very dangerous for International Space Station. So there's a team which keeps on controlling and monitoring if there is any particular threat in particular that zone. Anything which is in red zone is always dangerous for the International Space Station. So at that point in time, normally they will actually change little bit up and down if it is very dangerous or something which is going to. Some things which are beyond control, sometimes you really cannot see such a tiny, because the things, the objects, they may be very, very tiny in nature, but they are
yeah
moving in a very enormous speed in the space, which are not
yeah
also observable. So we do not have such kind of technology where we can actually monitor very, very small components,
yeah
micrometeorites, what we call. So it's
yeah
sometimes very dangerous, and we have seen a lot of time they have been hitting. So they have been covering provided to the body, the material what are being used, they are basically resistant, but then we can't always protect it. But that is what the job of the people who are sitting them and monitoring and keeping track of all these dangerous things happening to.
Sir, I would just like to interrupt you, sir, because I had done a project called as Stardust at Home, and
Hmm.
there we what we as citizen scientists used to do is that we used to check the microscopic slides of the particles which are hitting the spacecraft.
Correct.
So in that, even in the microscopic detail, the effect was so enormous.
Enormous. Yes, yes, of
Yeah.
course.
So, sir, since ISS has been revolving for 25 years, so
Yes,
so many micrometeorites or the interstellar dust must have hit the space station from the
definitely.
outside.
Definitely,
And
definitely.
but how do they actually repair it, or
Yes,
do they
yes.
what? So, but
So
changing the whole
if
body is
no, no,
really
it
a
is not
task.
changing of the whole body. So basically, see, basically the path is been situated in such a way where there is a possibility. That's what I was saying. There are zones which are being created around the
Yeah.
spacecraft. So that zone is been very carefully monitored. So anything which is dangerous, see, something is like small micrometeorites which hits and affects a lot of time. There are dents which have been seen on the International Space Station a lot of time, but it is not possible every part until it is very dangerous or affecting the functionality of International Space Station. It is not been repaired or changed or anything like that until unless it's very dangerous or could be a challenge for keeping the international space operating in the space. Then only it will be changed. Like there was, as I said, the cupola window was hit by the micrometeorite, and
Yeah.
something like that.
Yeah.
Then there were some small modules which were also not module. In totality, the entire module is not changed. Only the small components, or they have been put up. There are some what we call components which have been made with they reinforced back on that particular location where it has been hit. just to avoid any further damage to that particular location.
But just out of curiosity, but don't you think, like, if any part of ISS or any area of ISS is being hit by the micrometeorites very often,
Mhm.
and don't you think that part becomes weak? And because it is a micrometeorite, the effect is also in microns. So we are unable to see by the naked eye.
Correct,
So
correct.
don't you think that that particular area would become weak for the ISS, and it becomes dangerous for the astronauts who are there working in the ISS?
Yes, yes, of course. That's what I'm saying. It's a very dangerous part for it, and that threat is always there. The people who are staying inside the International Space Station, and that's why there are a lot of outside monitoring is being conducted, and wherever there, the ground team who actually keeps on monitoring the International Space Station on the integrity of the body and all the things. They keep on saying, and that's why these lot of spacewalks, what we see normally, these are basically for that purpose only, the repair
Right,
works and all that things.
right,
Like
right,
like you
right.
might have heard, there was, as I told during my talks also, that there was a ammonia leak was there, so which was
Yeah,
from the
yeah,
outside part. So it was
yeah,
not even the ammonia which was leaking. It was not possible for the astronauts to change by using the hand. Basically, they have to use an external grapplers, which was to be used, so that because it was very dangerous, and as you know, ammonia is very dangerous for humans
yeah,
to exist. So
yeah.
basically, a lot of separate tools has to be sent to get that repaired and all that. So it almost took 6 to 7 hours for that particular leakage to get repaired from the outside. So a lot of
Right.
these walks, whatever the space walks normally we saw outside, basically they are all the repair works of these things. So
Yeah.
I right now I don't, but I can share you those pictures also where the micrometeors have hit and there was a extensive damage from the outside. So sometimes, see, basically these components, what you see on the spacecraft or even they are not one single piece of component. They are always riveted or
Yeah.
so the module by module or small chunks you can change, or there are some components which are reinforced on the top of it. Okay, they
Okay.
don't change that particular module or that particular piece of the thing. It's like putting a patch or putting
Right. Right.
something, like there is some special material like a sticker is there, which can also be nowadays. It can say you can put it on the itself where it has got.
Okay. Okay.
So that is how you
Okay.
see. It is not practically possible to get the things repaired in the space.
Definitely.
Very
Definitely.
expensive. Even the
Yeah.
space walks, what you conduct, that consumes a lot of oxygen. Like, it consumes
Right.
components or the cargo of it. So, as I said, for simple sending a cargo to the space station also is a very expensive activity in itself. So they really need to
Right.
plan that one particular takeoff. They send almost a cargo of, for 6 astronauts or 7 astronauts, whatever it is required, considering that it will surface them for a particular amount of time. It is a full
Okay.
packed cargo. Like if you see in the inside the International Space Station, there is so many things lying here and there, and
Yes.
it's because they want to stack the things over there. So,
Yeah. Yeah.
right?
Sir, thank you so much, sir, for answering this. And one more question. Uh, Sir, as we know that many astronauts have been going to the space station, right?
Right,
Some of them live quite long.
right.
Like, for example, Sunita Williams was stuck up there.
Stranded there for almost 7 months, 7 to 8 months.
Yeah, for 7 months. So, like, we know what immediate effect she had on her body. But does any astronaut have some kind of long-term effect on the physical body also?
Oh,
Does the body
as such,
functioning or
yes.
something
We
is
have
also affected?
that is what
The base.
actually the experiment what they have conducted on one of the astronauts who was stayed there for long. I forgot his name. He was a bald astronaut. You might know.
Dr. Colin.
No. His
You're
name was.
talking about John Glenn.
I think so. They are actually twins. Actually, they are twins.
Ah,
Actually.
okay,
Yeah,
okay. The
They
yeah,
are
twins.
yeah.
twins.
Smith,
Sir, I think so. It's Dr. Colin.
Colin Smith, and
Scott Collin
Scott,
and
Scott Colin.
yeah,
correct.
yeah,
So those were the two, I mean, people actually, one a twin who was actually staying on the ground and one was there. So he almost like Collins stayed there for almost for 500 days, 500 and something
yeah,
days exactly.
yeah,
And basically they wanted to study how difference would be there on the body and everything, but there was not so considerably, because even though you are staying into the space station, they, apart from doing their day-to-day work, they also have to spend 2 hours on exercising and keeping them fit on the International Space Station. Yes, Sunita Williams, when she was earlier days, she was there, she did all those things, and that's why that point in time healthy. But over the period of time, like last time when she visited, she was actually not prepared for that long stay over there.
yeah,
And then since because of the issue on the return spacecraft, she had to extend her stay, and then we saw how it affected her body and all thing. But still, we do not have any results or output which were been released to the public on what effect it really had on her by that extended stay onto International Space Station. We still are awaiting what are the results or what are the inputs given with. But definitely, if you're not prepared or you're not planned things for that, it will definitely affect the humans into the space, right?
So basically, a
also
human being
for
need.
human being, even like if you change one location, like if I'm from Mumbai and if I go to Delhi, if I stay for a prolonged period over there, like if I stay for 1 or 2 days, doesn't matter. But if I stay for there for 1 week or 10 days, it really affects myself also, or any other location we go normally. So space is a vulnerable location for humans to there. So and that's why we have built International Space Station to study these causes and effects and how to overcome them, because that is what we are said, like in 16th century or 17th century, we were actually the ocean farers, okay, and now we are becoming a space explorers, and we need to see how we can explore the space, and we need to be prepared for it. Yeah, you are saying something.
Yeah, I was actually one more question has come up.
Yeah, please. No problem.
Sir, like we in astronauts who are being prepared or being trained to go to the ISS,
Right.
they are being trained in the space pool in the NASA area.
Correct.
Some of the which laboratory I
Yeah,
don't
they have
know that name.
basically they have to spend
Yeah.
almost 18 months prior their travel. They almost have to spend almost 18 months into the training.
In
Okay.
that pool,
Yeah.
sir, they spend.
Yeah.
But in ISS, actually, they are in zero gravity.
Correct.
So why are they trained inside a pool rather than a place where there is a vacuum?
So basically, there are. It's not only about the pool. The pool is only what has been shown us to on the YouTube or all the thing. But there are a lot of other things. Like there is a revolving mechanism where
the centrifugal chair.
centrifugal facilities there. Then even they are not only in the pool, but they are taken up into the space. I mean, into the atmosphere also, where the gravity would be very less and all those things. In those environments also they have been given that. So 18 months time where they have been put up into a different what you say modules, not only about the effect on the body, but also from a psychology perspective, because you are staying in a very confined space. Okay, like recently we have seen there is a test been going on in Ladakh on the Hope, where two astronauts from India, the two people from India who are selected, and they have been tested to stay how you are staying in individual in that facility for 10 days or 1 month or 2 months period of time. And like that, there are a lot of facilities available across the globe for studying the human behavior, human effects of such kind of environments over there. So it's not only about the pool, but it gives you an effect. It gives you an facility, like how the things, like see here, because of the gravity also assist us in doing a lot of things. Whereas when you are in a zero gravity, lot of things initially, like as Shubhanshu Shukla also said, that initially he felt, like though he was trained and everything was that, he had felt about the zero gravity effect for first 1 or 2 days. Okay, a lot of things which were easier for who are staying there in International Space Station, he was not able to come do those things very easily. Initially,
Yeah.
we always have that challenge. Like if you see whatever we do in a normal environment, and when we are inside the water, a lot of things we cannot do. We cannot move our hand or legs so effectively inside the water. So that effect we need to see how mentally, because a lot of time we need to mentally prepare the do things, or we have to train our mind to equip our body or hands or legs to affect or to take those command and do things. So we need to generate the scenarios where we get our astronaut trained from that scenario.
Okay. Okay. Sir, one more one more question.
Yeah.
Sir, sir, how many times can a space suit reach? Any idea
Sorry,
about that?
sorry. What
So
is it? How
how
many
many
times?
times can a space suit be reused?
Reused.
Yeah.
I mean,
Any
I
idea
don't think
about
so.
that?
See, until unless there is no damage to the internet, to the space suit, it can be used multiple times, depending upon the functionality, because there has been also evolution of the space suit over the
Yeah.
period of time. Earlier there
Yeah.
was the white color, then they changed to orange, and again back to the white and all the things. So again, there are different space suits designed by different organization. Right now, the spacesuit used by International Space are being developed while going from a Dragon's is being developed by SpaceX. Whereas if you
Yeah.
go on Soyuz capsule, it has been designed by the Russians and the Americans.
So does the color matter while we are designing the space suit? Like earlier
So
it was
earlier
white,
it
then
was
it was
white. White was,
orange.
yeah, earlier it was white. Then people change it for the color for visibility purpose. They change it to orange, but then they came back to white again. So it's
Okay.
basically to see in the against the black of the sky. They wanted to have something visible and easily spottable into the vastness of the space. That's why. So white
Right.
is preferred. So they in between they change it to orange, but then they are again back to white now.
Right, sir. Right, sir. Thank you
Good
so much,
evening.
sir.
Yeah, I think
Good e-
Tamanna,
yes.
yeah,
Good evening, sir.
good evening.
Thanks for the beautiful session. I'm in travel. Am I audible properly, sir?
Yeah. You're loud
Yeah.
and clear.
Yes, sir. Sir, I recently conducted a session in my school regarding the same about the information of ISS.
Yes,
So then only I came to know while studying the things that by electrolysis we make oxygen over there because we cannot carry a lot of oxygen in the
correct,
cylinders.
correct.
But what happens to the carbon dioxide that we exhale? So,
So
so
basically, if you see, it is a pressurized cabin, similar to like what we have into the what we call the aeroplanes. Okay, so wherever we are traveling in aeroplane, we are always traveling into a pressurized cabin. So basically, completely the entire this thing is pressurized cabin. So whatever oxygen you consume and you exhale the carbon dioxide, it basically the vents basically captures and basically it has been what lot I mean not what you say the hard or the liquid formats are not been thrown outside the space, but whatever the gaseous is there, it is been exhaled outside the International Space Station. Only the liquid component and the hard components are brought back to the earth for recycling or thing.
right, right. And one more thing, sir, like there we have to maintain like the pressure inside the cabin should be equal to the pressure inside our body.
Right,
But outside the space station, there is no pressure.
there is
And
no
there is.
pressure.
So
Yeah.
how do matlab, it the strength of the walls of space station that tolerates that pressure, or what it is, or there is some different technology?
So basically, these are all pressurized cabins. Okay, like same like what you see into the aeroplanes. Okay, so the structure is been designed, reinforced in such a way it's basically designed to withstand that pressure. So outside, you see there is a basically it has to be protected not only from the pressure but also from the temperature, because outside temperature is very cold. Okay, and then basically you need to make sure that the pressure what is there inside has to be maintained because of the human life which is there existing, so you have to maintain that pressure inside.
So according to you, the walls are able to tolerate that pressure.
Yeah, yeah.
And it is not that it is going to explode because internal pressure is very high and outside it's
Yes.
almost zero.
Yes.
Right, sir. So there is one more question. Like in because we don't feel gravity over there, though gravity is there. Uh, People might sometimes confuse that because gravity is almost 98% of Earth, and we don't feel gravity over there because it's at the we are
Outside the Earth, yeah. So there almost like zero gravity is there.
yeah. No, actually gravity is there. No, we don't feel gravity over there
We don't feel the
because
pull. We don't feel the pull.
we don't feel the full because ISS and we are also falling. Both of us are falling. So gravity is not gravity is not affecting us. But
Gravity is
gravity is
not affecting us.
actually 98% of the Earth because it's at very light, low altitude.
No, no.
If
So
we
as
apply,
Earth's gravity influence, it is pulling down. See, it is pulling down,
yeah,
but it is a very, very marginal level. It is pulling down. Okay, at a very, very, very minimal limit. So it's not that key as it is since it is in orbit, it is continuing moving around the Earth. It's not that it is in one location. It is has to be always corrected. It always has to raise its orbit also multiple times. Earlier, as
yeah,
I said, the first module which was sent it has the thrusters. So they used to use those thrusters to actually correct the altitude. Okay. So basically, gravity is zero. Why we are saying it? Because it is beyond the actual Earth's gravity field. Okay. So we
but if
can
you
see it.
say
There
if
are
we
two
apply
bodies.
the formula gr square upon r plus h square
So
and h
compared
is
to the
just
Earth's
250 kilometer, it is
compared
98% of Earth.
No, no. If you
But
see
we don't
compared,
feel.
yeah, because
But
if you see compared to the Earth's size and the mass, our
uh,
is mass is negligible, right? Compared to that.
yes, yes,
So that's why if you see our component is very less,
yeah.
right? So we will not affect by the gravity over there. Will not have the gravity effect on it.
Maybe I'm not able to catch you. I want to say that gravity is present over there. Because if we apply the formula gr square upon r plus h square to find gravity over there, it comes out to be 98% of Earth. But because space station is falling and I'm also falling if I'm in the same space station, so I don't feel that gravity. Microgravity doesn't mean that gravity is absent over there. But we are not able to feel that gravity.
Correct, correct. Because of the you are away from the location. You are not exactly on the Earth. So as you go up and up in the outside, you are basically outside the Earth atmosphere. You are not in the first layer of the atmosphere. Okay, if you are in the first layer, there where will be very marginally very away from the Earth. Here you are almost like 400 kilometers up in
Yes.
the sky. Okay, you are
Mhm.
still away. But when you apply that formula your presence is very, very negligible because to really affect the gravity. See, gravity will be there. See, anywhere in the space, the two bodies will always have their own mutual gravity on each other. But depending upon the distance, okay, depending
Mm.
upon the distance, it will have how much effect is going to happen on you. That's why we don't feel the gravity over there.
According to you, the Earth's gravity is not pulling us over there.
Pulling us there. Not that so effectively. See, it is happening since we are in a motion. See, if imagine if the spacecraft which is moving is slow down. If it slows down, it will gradually come down. It will gradually come down, and then one day it will crash into the earth. But then, since it is moving at a very enormous speed, we really normally don't feel that effect over there, and that's why we always feel that we are in weightlessness.
Yeah. So my question was that when the blood is pulled up, so our faces should get puffy. And it's a problem that the faces of astronaut get puffy in the ISS. Is it true or it is just a myth?
No, 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 it's not true. I have not
Okay.
seen like that. Wait,
Yeah, because I read it somewhere and I could
no,
not
no, no,
see
no,
that
no, no,
anyone has got this problem.
no, no.
Right, right. Okay. Thank you, sir. Thank you so
Thank you,
much.
thank you.
Okay,
Anybody has any
Mangesh
other
sir,
question?
we have one more question from Narayan Bajaj.
Ha,
Narayan, please go ahead.
So I have a small question.
Mm-hmm.
So when Amoli ma'am was talking about the oxygen in the ISS,
Mm-hmm.
you mentioned that we don't take oxygen at a whole. We use water and use the oxygen from it. So I just wanted to ask what we do with the hydrogen part of it.
I really don't know about what they do about hydrogen because I have not gone across this topic, but I believe that could probably they thought about using it for future missions for powering the spacecraft and what that's they had planned like. But right now, what they do it with that current hydrogen or whatever it is, no idea about it. Maybe I have to look into it.
Okay, sir.
So
Any other questions
basically, even the same is applicable when people thought about building the colonies on the moon. Since on the moon, on the South Pole, we see there is a ice which can be converted into the liquid water, and that liquid water can be converted into oxygen and hydrogen. So basically, oxygen is for the living life and all the things, whereas the hydrogen, which can be used as a fuel for future space missions and all that things. That is what is actually the plan, and that's why the initially when the International Space Station was built, initially we had to carry the oxygen cylinders and all the things, but then this electrolysis was conducted and they set up the plant over there, which actually converts the water into oxygen and the hydrogen part.
Thank you.
Okay, sir. Thank you.
Any other question? Mangesh sir, we have this NASNI as a National Astronomy Network of IAPT. And today we have a national president with us of IAPT, Indian Association of Physics Teachers, Professor P.K. Ahluwalia sir.
Oh,
I
thank you.
request P.K. Ahluwalia sir to give his remarks and about this talk.
Thank you very much, Professor Hemant. And I'm really delighted to express my gratitude to Dr. Mangesh Sutarji for such an
Thank you, sir.
excellent and detailed talk. I really want to admire you for your patience to listen to the questions and respond back. I think
Thank you, sir.
what a wonderful interaction we had, and you satisfied the participants with all the queries. I think this talk had very many elements which were very interesting from physics point of view and the kind of challenges which we face when we think of, say, that we are going to create space colonies where humans will be able to live. I think this is a small mini pilot for moving in that particular direction itself.
Absolutely, absolutely.
And, I was really very interested to note that, and there was a question on what happens if something strikes the ISI, and there are dents and there are so many things, and then you talked about that the design of the outer jacket of the ISI is a kind of a small modules which have been put and riveted. I was very much interested in hearing this word riveted, because we have almost forgotten the art of riveting, which used to be prevailing in earlier times by the blacksmiths while preparing things.
Correct, correct.
That's a wonderful art, and uh, and that holds things very fast. In fact,
Definitely.
this was one thing which was there. Secondly, 25 years means a big time. What a success it is.
Quarter of century.
Yeah, yes, order of century, definitely. It's very interesting to note this, and at last India could also get a kind of a slot, and Shubhanshu Shukla could visit the ISI lab, conduct the experiments of interest to uh, us in India in terms of our scientific intent and maybe technological intent. I think these are very nice, and I would say that this talk is a wonderful curtain raiser for the celebration of the Space Day also. It fits in very nicely into that idea itself.
Yes.
I hope, sir, you will keep on obliging us. And it is not that the people who are in this caste will be able to see it. We post it on our YouTube website also. So it reaches quite a number.
Yes.
And that is the purpose of NASNI, because we feel in Indian Association of Physics Teachers, there are a variety of interests which people have, and I think astronomy always comes on top. Everybody
Definitely.
gets excited and interested in it. So thank you once again, and thank you, Himanji, for conducting a series of these lectures. And I think you have sustained these, and you are bringing new and new experts. That is a great job which you have accomplished in the past 1.5 years. Thank you very much.
Thank you, sir. Thank you. Thank you for your kind words.
Thank you, Professor Aluwalia, sir, for your kind words. We have with our senior founder members with us, Madam Ranjita Deka, Madam Desai. If you want to give your remarks, please. Madam Ranjita. Madam Desai.
Yeah. No, sir. Something went wrong. I think I'm audible. It was really a very wonderful talk, and we really enjoyed listening to Astronomer Mangesh Sutar. He gave us a very vivid explanation about the ISS, and in fact, looking at it and listening to him, you feel I wish we could to go there and have go to the ISS and see the Earth from above. I just feel like that, but I know it won't be possible. But we can imagine ourselves like that, and regarding all the people trying to, all the nations together, they built up that ISS. And as Aluwalia sir said, even Modi ji is saying that we will also build our own ISS. That is why it is really very interesting today. Hope India can also do something like that on our own. That's all. Thank you so much.
Thank you, ma'am. Thank you. Basically,
Hello.
this topic is basically enlightening the younger generation of the people who will be of the future astronauts and future builders of International Space Station through India and collaboration with other countries.
Yes.
Hello. Hello. Hello.
Oh, yeah. Yes, sir, we have a new member from Assam. He is Mr. Kishore Borwa. I think he wants to say something.
Yeah.
Barua
If
sir,
you do not,
please go ahead.
yeah, if you do not mind, I want to add a few lines. Some people ask about the hydrogen. What happened with the hydrogen when we convert the water into oxygen and hydrogen? Actually, hydrogen is mixed with the nitrogen and produce methane, and it is actually pumped out from the International Space Station. So that is one way they neutralize the hydrogen, and probably they are thinking about that nitrogen with the hydrogen and converted to methane. They will probably use for future plantation and all these things inside the International Space Station.
Yes.
I hope you have got the point.
Yes, thank you, sir. Thank you very much.
Thank you, sir.
And then one question asked by some girl, I forgot the name. She asked why we do not feel gravitational pull of Earth. Actually, the International Space Station is falling all the time, and when something is falling all the time, we do not feel anything. And apart from that, when it is falling down, perpendicular to that, the International Space is going at a speed of almost probably 8,000 kilometer per second or 800 kilometer per second or something like this. So because of that, with the both the forces of gravitational force and this force, they revolve around the Earth. That is why we do not feel.
Do not
only
feel
see
the gravity affecting on us.
Yes. So thank you very much for giving me the opportunity to add those lines. Thank you very much.
Thank you, Kishore sir. Thank you.
Thank you, sir.
Yeah.
Madam Desai, please.
Yeah, first of all, Sir Mangesh sir, really thank you so much. We have been watching International Space Station as a small dot moving, wherein we can't even through our lens telescope, if we try to see, it goes very fast. We can't see that. And today you have shown us that it has so many big parts. I think it must be weighing more than 400,000 kilograms, and it's still there and working. Still working and giving us a lot of information, and a lot of astronomers have been still going there. And I think many of us who do a little bit of astronomy, everyone feels that, we could also go there. Thank you for this wonderful session today. And I would also say that today's session has actually come up with really very nice questions, and which we still need to think more about, whether it is regarding what happens to hydrogen from water, or it is regarding, say, micrometeorites, which
Meteorites.
based, yeah. And we also need to know about what must be happening to, it's not just micrometeorite, what must be happening to some of the asteroids, which may be little bigger. And definitely NASA must be having some way of maneuvering them, or maybe slightly shifting them. That definitely must be happen. But we have a lot of things to think. I mean, we have a lot of questions to think about it. This has left us thinking and to find answers to that. And at the same time, I think Tamanna had asked what Sir just now mentioned about the why don't we, and what about the microgravity there, and why do we call it a microgravity? Yes, there is a lot, because this question has to be tackled with different aspects. One thing is, we need to know that there is a free fall, right? Also, the just now Sir mentioned about the speed with which the International Space Station moves. If you count it in kilometers, it must be about 30,000 kilometers per hour. So that's why and it is also moving around the Earth, which is curving. So all these aspects, so we need to really think about that. So for me, that has really interested. And also, I am really saying that once again, I have been looking at it as a small object for so many years. And today I saw various, and we saw it as a package always. We didn't see it as those small parts which must be working. Also, I just want, it's not like, I know this is not the time to ask question, but what I understand is it is very big now. And then I think NASA must be planning to replace that by a small space station like that, maybe in your future, that would have much more capabilities, because technology has changed from 1995 till now. There has been tremendous improvement in the technology. Maybe we would have a smaller packet, but more instruments set up. Once again, thank you very much, Mangesh sir, for this wonderful session. Thank you, sir.
Thank you very much.
Thank you, madam. Thank you. Anybody else with the question? So I will request now Mr. Aryansh for the closing session. Aryansh?
Yes, sir. So on behalf of everyone, I would like to thank Mangesh sir for his fascinating talk on the International Space Station. Your insights into science, technology, and human collaborations amongst the countries for making ISS have been of great appreciation of this extraordinary achievement in space exploration. I would also like to thank Professor P.K. Aluwalia, Professor Arvind, Madam Ranjit Deka, Madam Amoli, and Madam Reshma Desai. Also, Professor Hemant sir, for giving me this opportunity to address this session. I finally thank all the audiences present and all the members who have asked professors such nice questions and made this session so interactive. Once again, thank you, Sutar sir, and thank you everyone for joining us in this session.
Thank you very much.
Thank you very much. Thank you, Mangesh Sutar sir.
Thank you, Hemant sir. Thank you, everyone.
And all the
Thank you,
participants.
sir. Thank you so much.
And see you in the next session, next talk. Thank you.